Welcome, dear Internet. This is one more time the Datamonsters. We changed our name since the last time. We are no longer a past regional group Berlin, and we are no longer past Germany e.V., but we are the Datamonsters now.
Correct.
And we have a completely new website, all hand built by Ben here on my side. And but we keep doing the same thing. We're bringing people together with data-related topics on the Microsoft background. And today it's a very rare occasion because we have Henning with us, who is actually working for Microsoft, and he's really working for Microsoft. He's not selling the stuff; he's creating it. Am I right?
Yeah. I think that's fair to say. Yes.
Yeah, yeah. And that is a very, very rare occasion because not for Microsoft, and then also you are doing something that I personally absolutely admire. You been working with Kusto from a very early stage, and a lot of people don't even know what this is. But I guess you will explain today. No?
Definitely.
No. Yeah. So we're about to kick this off, and I think basically, Henning, the stage is yours.
Mm-hmm. Wow. So first of all, thank you so much for the invitation. It's great to be here. Great to be in Berlin. Like very exciting day so far for me, and I was really looking forward to be here. So thanks again. I don't want to miss any opportunity to talk about graphs and Kusto. So it's for me topics that are really close to my heart. Just a quick intro. As Marcus already said, I'm a product manager at Microsoft in the Kusto team. I work out of Germany. It's not too usual. There are some people who work in R&D at Microsoft in Germany, but not too many. But you know what to do. I saw the technology at some point and just was falling in love with it and had no other choice than begging them on my knees to take this weird German guy and give him a position. So in our team in Kusto, and I'm going to use Kusto all the time, and I'm going to explain the family of Kusto.
Excellent.
In our team, I'm responsible for security topics. I know probably because nobody else wanted to pick it up. There's always the stuff with security, but it gives me quite some background of how the service is being built. So that's super interesting for me, like a lot of opportunities to learn. So I deal with stuff around identity, of course. We were talking about Entra ID, but also like even more painful network security and all of the different options. Right now, I'm deprecating a big part of network security, everything around VNet injection. What could potentially go wrong? You know, what could potentially go wrong exactly? And of course, usually it's a timeline of 3 years, and we made it in 6 months. So what could potentially go wrong? And dear customers, if you see that, don't worry, everything's going to be all right. It's just a button. And if I'm not doing network security and other security stuff, I started doing at some point ago geospatial features. So because Kusto, Kusto is a technology, is an append-only data store, which is collecting vast amounts of telemetry data. And we were dealing with a lot of automotive customers, and automotive customers at some point want to print heat maps. They want to know where certain things happen, certain calculate KPIs. But if you have like millions of data points, it's somehow hard to print heat maps if you don't aggregate or if you don't cluster. So I introduced the geospatial clustering, different algorithms in geospatial clustering, like a GeoHash S2. Sorry?
H6?
H3. Okay. Is there already an H6?
Yes.
I don't. Okay, it's a new one?
Not that.
Ah, okay.
You can get that from the Uber.
Okay, yeah, exactly. We looked at Uber and looked at those hexagons. Actually, they look much better than the stuff that we did with with S2 cells, and we decided to go for it. And
we did the same.
Yeah, and most of the investment went since then, like because there's like child-parent relationships. That's good.
And they want relationship.
Yep, that's right. And so, but if I'm not doing geospatial, I was like right from the very first days, I was telling the team, because of my past, which is kind of in graph databases and in like big data, combining graphs and time series, that we should have some integration with graph technologies. Because if you collect telemetry data, we were talking about the sensor data that you're accumulating, that you're getting from devices. And sometimes it's very helpful, not only like do like a flat enrichment of telemetry data with some master data. Sometimes you need to know the hierarchy of that device, of where is it located in like industrial IoT, like in which production line, in which production plant, in which site. And sometimes those hierarchies, they're not simple, so it might make sense to add some graph stuff. And that's what I'm going to talk about today. So graph semantics and why we added them. Before we go into any kind of technology, let's talk a little bit about the family. And I'm working at the lowest level of this family, and this is Kusto. Kusto was created 10 years ago on 8th of March in 2014, first commit. It's Microsoft native technology, super proprietary. Besides the language, query language is open source. Okay, it's under MIT. Yeah, it's a great product. On top of that, we released certain, like a lot of products which actually can be provisioned by users, first party and third party, so internal and external customers. This is the latest product that we have on the market. It's our latest and greatest SaaS offering by Fabric. It's called Fabric, and within Fabric there are like different parts, and we are parts of Realtime Intelligence.
They love to call them
workloads, right? And within Realtime Intelligence, there are interesting services or workloads such as Event Stream. But there's also another service which is called Event House, and under the hood, the Event House is Kusto. Okay, just a SaaS version of it. Our flagship product still, like based on the market adoption, is Azure Data Explorer. It's the PaaS offering of Kusto. Like we have like hundreds of thousands of customers and clusters deployed. But probably this is something that not too many people know, and we are very creative with names. It's Kustainer, so it's a Kusto in a container. It was essentially built for disconnected CI/CD scenarios, where customers just go and deploy have their CI/CD pipeline not talk to an Azure Data Explorer cluster, because there's also some money involved. Okay, so do it disconnected with the Docker container. A couple of things that you should know: you are not allowed to use it for production workloads. Okay. If you have some serious issues with that, just come and talk to us. It's at the end of the day a full-blown engine, and it has the same engine capabilities as any of the other offerings. So it's actually really cool. Things that you might know, or that like a lot of people know, is Azure Monitor. So whoever creates like some apps, or whoever is doing security, all of these kinds of workloads are built on top of Kusto at the end of the day. Also, if you're into gaming, and like there are tons of other services at Microsoft where under the hood this technology is being used. I still need to come up with numbers because not too many people know about Kusto. I still call it Microsoft's best kept secret. But that best kept secret, at the end of the day, it's a distributed relational database which works on a column store. But that little friend is ingesting around about 300 petabytes each and every day in a relational database. Okay, and we manage to ingest per month roughly 8.3 exabytes, and the lower left number is wrong. It's 5.5 million cores on Azure, which is not like it's not like super huge, but non-negligible. Depending on how you count, it's roughly 450,000 KQL developers. And what's also really cool to see is that all of these numbers, they don't come from, I don't know, somebody like Satya or one of our earlier CEOs demanding that people are forced to use Kusto. It's like it grew organically within Microsoft.
So, question.
Yeah, sure.
How do you count developers? I work with App Insights and write a query for logs. Am I a KQL developer?
Yes.
You're writing KQL?
Yeah.
No, I think in that moment you're just because log analytics under the hood I can't talk too much about it, but they're not using your identity up to the lowest level. Okay, they impersonate with a different identity. So you would, like all of you on this table and everybody of us will count as one person. So we don't even count that. We also don't count Azure Resource Manager users, because there's also Kusto under it. We also don't count that. Like just Azure Resource Manager has roughly, I think, 5 million users, a little bit more. The Log Analytics, probably along the same lines. We don't count that.
Log Analytics, that seems
Yeah,
very low.
no. This is just like people that type Kusto stuff. We're not we're not even counting app IDs. So service princess, we're not counting that. Just real users. Yeah. Don't try to bullshit too much. So that's Fabric. I don't know why I put it in these slides. As I said, it's our latest and greatest SaaS offering. It's really cool because we allowed ourselves to have an opinion of how certain things should behave. For example, in an Azure Data Explorer cluster, you had to exactly configure your virtual machine type and how many virtual machines you want to have. On Fabric, when you deploy an event house, we are going to deploy like under the hood a virtual cluster, and you don't even see the underlying infrastructure. And you can deploy it within a couple of seconds, where on an Azure Data Explorer cluster, it might take 10 minutes until all of the virtual machines are started. So it's like way easier to interact with it. And it's just a SaaS version of it. And it works really well together with the rest of the ecosystem. Yeah.
How do you name Synapse? It's still Synapse, right?
Synapse? Yeah.
Okay.
So
offering.
So that's brackets deprecated.
no, this is not coming from Microsoft. Somebody in the room said something. So no, I mean, there's obviously, like, Microsoft has quite a journey, okay, behind it, and we created like a ton of PaaS services, a ton of PaaS databases, and then we had our first approach with the Synapse still working in the Azure environment, and it was the first attempt to be able to have like multiple services work like better together, not against each other. So that was the first approach with Synapse, but like Fabric is taking it to a totally new level. The underlying platform is totally different, and the way that you are dealing with it is totally different. Completely different worlds. But you're right. Like we still consider it as a major milestone for us. Power BI is so. Yeah, you see, yes, that's, yeah.
They're all good friends.
We're all good friends. We are in one big team, one big family, and yes, that's true. I don't know why I put this slide in here, but I think it's not a terrible idea, but you should know about it, okay? I'll tell you a bit of a story about it. Like, if you're reading documentation, at some point it can get quite boring. Who of you know the Kusto Detective Agency? You did it? Which season? First one, second one? So you know who Professor Smoke is. Okay, so I find it quite funny. Last week, Professor Smoke, which is me, I'm playing a character in that season, was in Amsterdam. So that was quite funny, also for business reasons. And when it's about telling a story about technology or allowing people to learn the technology in an easier way, like less painful, we thought about, let's build a game. Let's build a game, and we call it Kusto Detective Agency. And the idea was right from the beginning, where you started, to have a case each and every week. You start as a rookie detective, and you climb up in the ladder. You get credly badges. You get some Amazon gift cards if you finish a case. And each and every case gets a little bit more complicated, uses different features. And after you finish the Kusto Detective season, you can write some decent KQL, and you know how stuff works. We had a first season, we had a second season. You see here, like almost 20,000 players played a game about a database. Like, what the heck? And even in the second season, like if we're talking about the feature, which I should talk about today, we had I released the feature in a game. So I think in the 9th case of Kusto Detective Agency, we publicly released the Graph Semantics, which we built, which was super fun to do. And we had Scott Hanselman in the call, and like the next season is even going to be bigger. And we created this slide. And if you have some feedback to share, please share it under this URL. The tentative plan for next year, for the next season, is to start early next year and have a competition over the weekend. And there are teams who work together. Teams can like work together, and the fastest team wins. And it's not just like winning, I don't know, this little pen, PepCon tickets, which is also great. But the first prize is going to be a whopping $10,000. So whoever finishes this competition first, I've not seen that at Microsoft before, but I'm not too long at Microsoft, but I have not seen that before. So the first team wins a prize of $10,000. And, you know, sitting together with friends over a beer, but I don't know if you can afford beer if you want to win the $10,000. So, and yeah, so that's the plan for the next season. If you have feedback, just share it. It's just an awesome way. Like the feedback that we're getting for this thing is great. Like people say we start with KQL, and it's now like they're the start of the journey of the professional career, and that game helped them really to develop skills that they couldn't get anywhere else. Okay, let's talk not about roadmap stuff. Let's talk a little bit about graphs and why we actually did it. Like graph is a concept, a mathematical concept, which is focused around nodes and edges. There are like specific types of graphs. At the end of the day, what it's trying to do is trying to look at data in a different way. And here it's something that is it's called the labeled property graph. So you have nodes which can have properties, you have edges which can have properties, and edges connect the nodes with each other. And you can build like many things. We talked about connected assets, knowledge graph, just hierarchical data, like hierarchical, for example, I don't know, social networks, for example, many-to-many relations. There's ton of examples for that, and graphs are essentially everywhere. Now, why did we build it directly into Kusto? Why did we have to extend the language? Reason for that was because of security stuff, which is super important at Microsoft. So we were funded with, like the way that it works at Microsoft is you need to ask for funding. And ask for funding is not exactly the same as doing an investment, like multiple investment rounds, but kind of similar. You really need to go to like high level people and explain your scenarios, your business cases. You need to have partners on board. And we were funded by internal security teams to extend the query language because of certain features that they would allow for their users. And so we actually did that. And this example is now leading through the journey of a Kusto query and how it changes over time when you switch from a classic relational algebra to a graph algebra. And the graph stuff is just simple social network. Some person knows a different person who knows another person, and then it's called friend of a friend, classic scenario. And you can do this already with existing Kusto, just by using joins. But joins over time, if you look at it, it gets quite ugly and like quite messy very, very quickly. So I bet there's a bunch of, I don't know, 60 years old SQL developers who are doing this already for 40 years. They laugh about it, okay? But I would say for the majority of people, at some point, having like multiple joins is like very hard to read, right? And also at some point, it gets to its limits. And what was not possible with Kusto, with the existing relational algebra, is those kinds of recursive joins where you actually don't really know when to stop. So you define a stop criteria, but the stop can be sometimes after one hop, but sometimes after 3 hops, 5 hops, or 255 hops, okay? You don't know. And this kind of recursive join capability did not exist in regular Kusto. So we built these beautiful graph semantics. And there would have been like multiple ways of implementing it. We decided to do it the right way and embed it directly into the language. In our first approach, embedding graph technology in Kusto was implemented in a way that we called an external service. So we call it Azure Digital Twins, for example. And the way that it worked was you have a plugin that you evaluate. You say evaluate Azure Digital Twins, and then you define an endpoint, an API endpoint, and a query. So you send the string over the wire. But the problem is you lose the entire intelligence capabilities of Kusto. You just send a string somewhere, and you don't really know what it's doing. You can't work with variables in that. It's like super complicated, and we wanted to integrate it deeper. That's why we decided for this combination of like two major operators, and now we're in the process of extending those operators. So we start here from a relation or a tabular expression, which is called knows. That's just something that's called an adjacency list. So A is connected to B. So a first user is connected to a second user, and then you can provide a couple of types to it. And without edges, a graph would be super boring. That's why we made them mandatory. And you can say, once you have this list of edges, you make a graph and you define the first user is connected to the second user. And then this is actually already enough to create the graph. But then sometimes you want to enrich the information on the nodes, and you give it some information about the nodes using this tabular expression, which is called users, which consists of a user ID, name, and an org. And you say, okay, those nodes, how do you actually want to enrich this information? Which identity do you want to use to enrich it? And this is what you do here in the last step. Now, this already creates you a graph, and then based on that make graph, you can use like multiple graph operators on top. This is the most important one, is called graph match. So we looked at multiple graph database query languages. We looked at Gremlin. We looked, of course, at OpenCipher. And for us, the kind of ASCII art of defining paths in OpenCipher resonated much more with our feeling for ASCII art and query languages. So what you see here in this parenthesis is a node. In the brackets is an edge, and it's a directed edge. It goes from a user to another node, which is a friend of a friend. And the most important addition here is this so-called variable length edge. So this edge can be 1 hop and up to 3 hops. So you read it in a way that the user to a friend of a friend relation can be at least 1 edge, but it can go up to 3 hops. Okay, this is compensating this recursive join operation. Under the hood, we didn't use joins at all. During this make graph statement, we are creating an in-memory graph, which consists of essentially like 2 Rust objects, one representing the graph, so the object, the graph object itself, and the other one is representing all of the properties in a column store. And we were reusing the Kusto column store because in the second part of the graph match operator, after the path pattern, you can define constraints. And in those constraints, you can use the entire bandwidth of Kusto. So all of the Scala operators that are available can be reused in the constraints. And then you need to go back at some point to the tabular world. And this is happening here in this project clause. And that was actually the main addition. And then if you look at it if you zoom out a bit, like why the heck should you do that, or should you use it? We have a ton of customers that store, as you've seen, petabytes of data in Kusto, petabytes, exabytes. And if you already have that much data in Kusto, you ask yourself, if I want to enrich the data and provide some context, do I want to have another database on the side for a very small graph operation that I want to do? Or do I want to bring some of the graph logic directly to where the data sits? And we find a lot of people that say, hey, it's actually not too bad decision to move this logic to where the data sits. We might not get 100% of a real graph database, like Neo4j, Tiger Graph, memgraph, all of them, which are beautiful, but we don't need it. And we already have all of the data, so why not bring some stuff in? This, at the end of the day, reduces the cost of a solution, also the complexity. And during our implementation and experimentation, we actually found out that we are pretty good with another feature, and we call it time-aware graphs, which means that we can create a graph at a specific point in time, because we look at graphs as a time series. So a node is being added, another node is being added, an edge is added between both of them. all of them are timestamped events, and we can easily create a last known state of this graph, but we can also go back in time. If you model something like this with a classic graph database, this can become quite messy because you need to model it somehow in the edges, and then you get like way more edges than you actually want. So your queries might get slower and your graph gets just bloated, okay? So that's something that I consider as a USP. And then at the end of the day, KQL, for people that love KQL and having it embedded directly into the language, it's a really good option. Okay, so we are right now in this phase where we actually taking tabular expression from edges and nodes and creating a graph. And what we're building right now is a second phase where we're going to have an entity, a real graph entity in Kusto. So we are completely extending the database with a native graph entity. This is very exciting because it's the first time that something else than tabular expressions made it directly into the engine.
Will you be using the same statements even after you put it into the engine? So
Yep.
the statements will remain the same?
Statements will just remain
remain
the same.
implementation then.
Yep, exactly. So you see here at the moment, you still need to make graph, to create your graph, and then you have a persistent object, and you can do the same operators on this one. And then you can pick and choose. You know, sometimes it makes more sense to use the persistent one. Sometimes it makes more sense to use the in-memory one. Customers can pick and choose, but logic stays the same. And because we added it at the bottom of the stack, it suddenly appears in all of the other things as well. So we added it in Kusto, so you can have it in Kustainer. And your container is now not a graph database, but it has Graph Semantics. It appears in every Azure Data Explorer, in every Fabric event house, in every Azure Monitor workspace. Everywhere, suddenly now you have graphs.
What surprises me is, I mean, always when I work with Kusto, I'm amazed how fast it is. Extremely fast it is.
Yeah.
And without any tuning or whatever.
Yeah.
And isn't that a very good reason to put graphs inside? Did you check the performance? Isn't it simply faster like that?
Sometimes.
Oh,
Not,
okay.
you know, it's all pros and cons. I looked at it as a PM. And then I look at it, what's the investment for us to make it persistent, to create a persistent graph versus creating it during query time. And I looked at the numbers, and the numbers for creating a graph for, let's say, smaller size of like 1 million, maybe 5 million edges, it's the 90th percentile is less than 100 millisecond, depending if the data is already in Kusto. Because we're using tabular expressions, which means sometimes you can also go to a storage account or to another database, and then we need to make outgoing calls. So it's not directly close. If it's not directly close to the engine, of course, it takes longer. But if it's directly close to the engine, it's like 2 digits that you invest, and then you have your in-memory object. And after your query, you throw it away. No maintenance of graphs, no nothing. You just throw it away. You can just work with your existing data sets. Very easy. But of course, if your graphs are getting larger, let's say billions, 10 billion, 50 billion, 100 billion nodes, at some point it makes sense to persist it. And that's where we are, because that's also the scale of our customers. We don't do it because Henning has this bright idea that we need to be like, that we need to persist it because, yeah, that's a beautiful idea. Let's put a couple of engineers on it. No, it's like the demand that we have forces us to make this investment, and it's great, you know, because we have those customers. And for us, it's a blessing to have those. I was just talking with you about your customers, and you know that it's sometimes hard to get in, but if you are there, then it's great. And we have this kind of the same situation. And for us, it's just beautiful, you know, those large customers, very demanding, and they need it, and we help them with that.
And unfortunately, you cannot actually mention who they are, I guess.
Microsoft.
Yeah, I mean, that's of course the customer. And they probably treat you like an external customer.
No, it's, you know, we are a big family. But
okay. Family thing again. Okay, I remember family something. Yeah.
No.
Christmas is near.
Yeah, no, but we are very fortunate. Okay, so let's do some demo. Okay, so where do we start? Let's not start with Teams.
We'll be using a Kustainer.
We can also use a Kustainer.
No, you don't have to. I was just asking.
No. We can do that. We can do that. So lately I started doing my experiments and of my demos in Fabric, because it's actually not that bad. What I like about it is the capabilities of saving something and being able to get it back. Sounds very simple, but it's sometimes very useful if you change computers very often. Okay, so I don't know.
It's saved in the Fabric environment.
Yes,
You get your
correct.
queries back.
Yeah. So I talked a bit about the Microsoft size. I'm right now connected here to Couscous. Did I talk with anybody about Couscous? Kusto is the largest Kusto cluster. Kusto is the Kusto cluster of Kusto clusters. It's getting all of the log and telemetry from the entire world.
Oh.
And it's even bigger than that, because we as Microsoft, we have a promise to keep log and telemetry data in the region where it originated from. You know, those data residency promises that we give, and they're very important for us. So Couscous is not just a single cluster. Couscous is a head which can be connected from everywhere. And under the hood, you have entity groups of clusters which are in every region. So if I'm now querying this, I'm under the hood querying all regions at the same time and look at the size. And for example, we have a couple of tables in here. If I look at, for example, Kusto, we not go to Kusto Financials, okay, not today. If you take a look at the count, this is just 181 trillion rows. Now we can also, it's just, and I query it like this, and now I'm querying, I'm going to all clusters, okay? I look at the last 5 days. For every ingestion, we get the size of the original data packet. Let's say 1 gigabyte was ingested per ingestion, and then the compressed size of it. The compressed size is like factor 7. That's what we are saying, smaller. And then I'm aggregating it by timestamp by 1 day. And then I'm only picking the one which is the highest. And then I'm formatting it as bytes. And what you see here is we have clusters. We ingest per day on a single day, a single cluster, 6 petabyte of data. And we compress it down to 400 terabyte per day. Okay. And the good thing about Kusto is, unlike other services that I'm not going to mention, you only pay for what you actually store. So if you send us this 6 petabyte of data, you're only going to pay for a 400 terabyte, which is also quite a lot, but it's less, a lot less.
What about ingress cost, like network ingress?
Like ingress, we are very generous. We are free. My ingress is always free at Microsoft. If you want to get everything out, it's a different story.
Yeah, but you don't want to get it out from Kusto, because you have all these amazing queries that give you a very tiny result.
Correct.
You get out a tiny result.
Yep, that's the point. Yeah.
How fast would it be in Fabric? You have the possibility to sync the data to one lake as it arrives.
Yep.
If you sync 400 terabyte per day, is it still immediately, or what?
So the feature is called, I believe it's one lake availability.
Yeah.
And on Fabric, it can go in on an event house to any table or even to the database and can say, make data available on one lake. And then if there's already existing data, we are streaming it out to one lake and store it as data parquet. And every new data set that's coming in is also going to be stored. I'm not sure if we tested it at that scale, to be quite honest. I shouldn't be probably saying that here. But with our customers that we have on Fabric, it's working like beautifully fine. We invested a lot of time in making that streamlined together with this one lake availability.
I mean, I find it interesting that Kusto is basically the only service that is now marketed under Fabric, where the original format is not Delta Parquet, but the original format is Kusto database.
Yes.
And then
correct.
you can say, make it available in one day. So
Yep.
you are the only system that goes the other way.
Yeah, we might not stay the only one.
Oh, okay, probably.
But that's true.
Yeah.
But I guess the cost for 400 terabyte storage in Kusto is way less than 400 terabyte in one lake storage.
I think it's comparable, because we're not doing like, I think the costs in one lake are comparable to what you would get with an ADLS Gen 2.
Mm-hmm.
And also like the compression is pretty much the same if you're storing it as data parquet compared to what we're doing. Like both are column stores. Compression is equally good. Like Kusto has a bit of an overhead for a reason. We are a database, so you want to have secondary indexes. If you have it on one leg, it's nice, beautiful, nice, but you need to have a proper partitioning to make it work. And then even then, you don't have secondary indexes. So Kusto stuff is still faster. But there will be like some nice announcements at Ignite, and I can't steal the thunder of Ignite. I don't want to do that. Otherwise,
Yeah,
it will be problematic. But in a week or two, I believe you will know.
At that scale, if you want to have relational database for querying or whatever, it would be better for performance to store your data in a Kusto database than in one lake and with a lakehouse or whatever, just for the query performance with the indexing and everything.
I don't know. In some scenarios, customers really think about like how many different services do we have to combine, and sometimes they just say, I don't want to have all of this complexity. And relational database like data warehouse and lakehouse, they are a bit more optimized with their joins than we are, so to be quite honest. But we're also working on that. So if there might be some edge cases where it's actually better to have like just a pure lakehouse. But I would say with Kusto, you can also do like 90%, 95% of all of these cases. Yep. Okay. So this is a couple of like other things, other demos, but I guess we only wanted to talk about Graph today. And how much time do we actually have?
as much as you want.
Okay, cool.
Maybe not.
There's
Okay.
still some beer left. So.
Okay, good. So let's start with something similar. Is it big enough? Yeah, it's okay. So that's just a simple like reports table, a data table, and that's one of the first examples that I usually bring because it comes with something like a social network. Everybody can relate to that. So you have employees that report to managers. This is something which I released this last week at KustoCon, where you don't need to have the extra tabular expression for nodes. You can just derive it from the edges table. And what you see here is let's create an in-memory graph and then do a graph match where we start at one node and go to another node. And I'm starting here with Henning. And I want to have the path through that. And to execute it, that probably is
You're actually using the development team, am I right here?
Yeah, exactly. So I report to Avner, Avner reports to Uri, Uri reports to Odette, and Odette reports to Itzhak. Itzhak is this CVP or VP, I don't know, CVP probably, of Realtime Intelligence. And he reports to Arun, and Arun to Scott, and Scott to Satya. Yeah, but something that you see actually more often in Kusto is like people just storing raw logs. And then the interesting stuff is like, what can you do? Like sometimes also call it retrofit. What if I just store logs for now ages and I want to be able to use them with some kind of graph technology? And what you see here is just IP addresses with a specific timestamp. I think it's an Apache log that asks for a specific resource and then some other information. And then what we're doing is we're taking those raw logs and we use the parse capability. That's something like a simplified regex. I just learned how much I actually hate regex, and I forgot everything that I learned about regex. And like every time I'm starting again with regex, I have to start from scratch. And this, like for those not so regex proven people like me, this makes it very easy. So I'm getting here the parse logs, and then I'm creating my edges, which represent the parse logs. I'm creating some information on the nodes, some other Kusto stuff. And then I just say in the graph match from a start IP that makes a request to a resource. And it's also, you can explain by just reading, okay? And that resource is also queried by another IP address from another request, which also queried another resource. So you can tell a story by just going through that. Imagine doing something like this with a join. It would have been not that easy to fully understand what you're actually doing. Then you have the constraint section, and here we want to have like requests which happened to the same resource. It's something like a co-occurrence recommendation algorithm, like a super small, super simple one. And then it can say, okay, those requests, they need to happen like in less than 5 minutes. Otherwise, we don't find the path, and you just execute it and get it back. And it's not super interesting. Okay.
One question.
Yeah.
Sometimes those basically arrows that you define in syntax, sometimes they have 1 minus and sometimes 2.
Yeah.
What's the difference?
I can explain. So what you see here is everything that's in here. That's a vertex or a node, and everything in those brackets is an edge. If you don't have this is an anonymous edge. Okay, I only need to have this specific one if I want to use it later down here in this part. Okay.
So the other arrows also have 2 hyphens, but
Yep.
they have the name in the middle.
Correct.
Yeah.
I could also just do
Yeah.
like add here, and it would also be okay.
Oh, this is how you name it.
Yeah,
So,
exactly. That's just the naming. Think about like a variable. I could also say like foo and r and whatever.
So basically, you name it if you want to
Use it in the constraints. Yeah,
Okay.
exactly. Yeah, correct. So
That's neat.
yeah, it's very simple. If you understand it and you have used it once, you don't think in anything else any longer. Everything looks like a graph, and then it's like very contagious. This one reminded me a bit more on your scenarios. This is like an IoT scenario here. And what I'm doing here is, first of all, I'm interested on a specific day. So what happened on a specific day? And then what the classic like bread and butter business of Kusto is something like this, okay? I'm looking at a time series on a specific day, and then I'm creating a time series essentially. So I'm translating rows into vectors, and then once I have it, I'm filling up missing values, and once I filled up the missing values, I'm finding anomalies, and then those anomalies are tagged. So I get a bit field, a vector field. No, which we're representing for it. You can just go here and say it's to assets with anomalies. Oh, I forgot this.
This is the way you output it. Yeah.
Exactly, and then you go here and you see, for example, there are a couple of assets, 60 assets which have an asset ID, and then they have a couple of arrays where all of them have the same length. Okay, the most important one is the timestamps. And then for every timestamp, for every index in all of those arrays, you get the corresponding value, for example, here in values. And here are, this is for the anomalies. We get just this a simple array, and I believe I don't know if there are anomalous assets in here. Yeah, there's a negative anomaly here for some reason. At the end of the day, it's just sample data sets. I can show you some some more interesting data set, but it's all built-in functionality that comes with Kusto.
Bottom where there's a 1.
Yeah.
Oh yeah, minus
Yeah,
one,
exactly. -1. Right.
Oh, okay.
Yeah. Okay, so
By the way, nothing really interesting happened on April 17, 2017.
yeah, not really that much
I just
happened.
looked it up on Wikipedia, nothing very interesting happened.
Okay, a good catch. Okay, so now the only problem is that I don't know how to get back to this.
Because you haven't used.
Yeah. Okay.
Oh.
Thank you. Okay. I see. I didn't finish my Fabric certification.
Detected season 1.
Yeah. Now, detected season 1 is not something with Fabric, but I don't want to spoil what's going to happen in the next one. Okay. So once you have that, I'm just flagging stuff, and where there's a 1 in here, I flag it as an anomaly. And then what I'm doing here is I'm getting the nodes, and this is a function which I wrote, like a very simple one. I'm just going through all of the node events and construct the nodes at a specific point in time. I'm adding this information about assets which had an anomaly, and then I'm getting the hierarchy of those assets. Like this asset is connected to something else. I always make up the example of a pump which is somewhere in a, I don't know, in a shop floor, and that pump has a pressure sensor, and that pressure sensor has a couple of anomalies. And now I would tag actually the pressure sensor which it has an anomaly. And then this is a so-called blast radius analysis. So I try to find out if this specific sensor is showing too many anomalies, what is going to explode, what is going to stop working, if that asset goes like berserk, doesn't work any longer. And then yeah, exactly. So I start with the asset, and then I'm to production line, and then to the factory.
Oh,
Something joining us in Teams.
yeah,
Someone joined us in Teams. Our dear ex-colleague.
yeah.
Okay,
Yeah.
amazing, nice.
Yeah.
So, and that's also something that's quite hard to do if you're only using a graph database. And that's why I love to bring those kinds of examples which combine time series data with non-time series data and graph data. What we're doing like most of the time is actually security stuff. So also this last KustoCon last week, it was mostly on security. So blue teams, red teams, people that are at Black Hat or DEF CON conferences, they're breathing KQL all the time. This is something that's called Bloodhound. So it's like offensive security, trying to find who has access, for example, via RDP to a computer. And this is a Cypher query from Neo4j, and they took some example data sets, and this is the way that they are writing it. So a user can RDP into a computer, then please return something. A user is a member of a group that can RDP into computer. And here it can be actually like way more complex. There can be like nested group relations, and sometimes some additional constraints. And the same way you can do here, like it reads almost similar. And we're also making this even more simpler. Yeah.
Yeah.
Yeah. Yeah, exactly. And you know, the result is not too important, but the thing is, what our customers told us is your joins are nice. They're working well, but no, people don't understand them at a certain point, and you can't, it's hard to offer it to customers. And we want to have like an easier notation for certain things. Yeah, so that's what you can do here. And then there was a very famous, some time ago, there was I think this March, I think I can talk about it. This March, there was a supply chain attack, which was like almost destroying the entire world of IT. And all of us can be very thankful that there's a Microsoft developer working on Postgres who found out that something like super weird is happening in his software. That person is Andres Freund. He's working out of Sunnyvale. He's a German, by the way. He was even in the Bild Zeitung. If you read it, crazy. And you know that meme where there's this entire software stack, like a Lego blocks built on top of each other, and then at the very bottom there's this one little Lego thing, and this is like one open source project by just one maintainer. And if that one is not there, the entire building is collapsing. That's what he found, okay? So he recognized that while he was debugging the authentication on a Postgres database, that it took a little bit longer, probably a couple of nanoseconds longer than he expected. And he did research why that happened. And there was some developer on GitHub who invested 3 years of his life to pretend to be a legit open source committer. And then after 3 years, he starts an attack on an open source project by injecting malicious code, which which was on the way to the Linux distributions, to OpenSSL. It was, I think, XC utils, and it was infected, okay? And he found that out. And we had to do a pitch for a CVP and thought, a security CVP, and thought about what can we demo to these guys. Thought, okay, so we have GitHub data. Let's do GitHub. because we have all of there's something that's called GitHub Archive, and all of us can go there, fetch the entire GitHub archive, put it into a nice database like Kusto, and then use it to do research. It's of course just public profiles. We can also probably test one of your accounts if you like, but I used mine, but because I didn't want to like blame any people that I don't want to blame, okay? Because we were also in active investigations with certain companies. So let's show what we actually did. So let's first have a look at what GitHub data means. And as I said, this is all public data, okay? No worries. We're not like having any private data, okay?
This is the good old Kusto Explorer.
This is the good old Kusto Explorer. It's you know, all of these web stuff, I don't know what it is. I don't think that it will last very long. Like desktop clients will come back. No future for it. And let's have a look at how big it actually is. It's also not too small. It's almost 8 trillion, wait a second, billion rows. And if you look at just at the events and at the data set, like each of these events has a couple of columns. All of them are essentially dynamics or JSON. The Kusto data tape is dynamic for that. And it has some information about the login, the repository, what people did with it, and some other information when it was created. So like a lot of information. And what we're doing here in this calculation is we're looking essentially here at 3 years of data. We're filtering it here to 3 years. Then for the 3 years of data, we're extracting the actor and the repository name. And then we wanted to find out what was the social network of the attacker? Who helped him in pull requests to make him more prominent? Who helped him? Who pushed him in issues? To find out like who were the other people who actually, because those people that they don't act alone. Like Microsoft is constantly attacked by nation-state threat actors. Nation-state threat actors, there are like thousands of hackers, which is their job to do that, okay? So we wanted to find out who were other people. So we wanted to find suspects. So we looked at pull requests. So based on all of these events which we filtered over here, we looked at pull requests. We looked at issue commands, and we tried to find bots because we wanted to exclude bots who were making like too many commands, okay? So if you want to hide yourself, you really need to be like super active or not active. Exactly, yes. But you nation-state threat actors, you didn't hear that, okay, on the stream.
And are they, I guess there's an abbreviation for nation-state? Is there an abbreviation for them?
Yeah, let's say some of our internal code names might be Frosty Speed Bump or Kusto Giga Bounty.
Okay. Internal code names, okay.
Yeah. Now, what we do here is then we create actually a graph, okay? Very simple. I don't think that you even need this syntax over here. I need to fix it. And then we say we want to have we start from an attacker that interacts with an activity. And then it's a couple of edges to the suspect. And you start with the interaction, so interacts with Kosh. So usually Kosh, that's my GitHub name, okay? And for the bad actor because we know who the bad actor is. It was also reported everywhere, but I don't want to go there. And then we create the suspects, okay? After we found the suspects, we're just using regular Kusto to calculate the score based on the weights that we defined over here, and then calculated the top 10 suspects by score, like super simple. And then you get this list, okay? As all of these lists are probably like people from my team. I don't know who American Dipper is. So sorry, American Dipper, if I have you.
Very much interested in your work.
Yeah, and then, you know, we also we work a lot with security people, and we want to know like how they are interacting with graphs. So now I have the suspects, and again, now I'm running on the entire data set. So I'm data sets in 2016. And I'm creating graphs. I mean, this is not like magic. We did this because, you know, like Kusto is not the best tool for doing like beautiful visualizations, but we have quite a talent to listen to customers and do something that triggers the imagination of what they would be able to do. Okay. And what resonates like super well with security analysts is having it in 3D. And then, of course, for security people, everything needs to be in a dark theme.
Yeah.
And then you have a nice 3D graph, and you can look at specific things, and you can search for example, this weird guy, Kosh.
This is going to be part of the GUI of
Yeah, no, this is part of our GUI of Kusto Explorer.
Kusto Explorer.
Yeah, but you know, we won't stop at Kusto Explorer, but that's where it is at the moment. That's the easiest one for us to integrate. Yeah. The person who has to get all of the kudos for this tool is Alexander Slutsky. He's one of our founders. We have 4 founders: Odette, Evgeny, Ziv, and Alex. And Alex is the owner of this tool, and this is a Microsoft critical tool, by the way. This is not a game. It's like it's a list of critical tools for Microsoft. And then once you found something that's interesting, for example, here, like, of course, usernames are red, and the green ones are repositories. You see, I'm working a lot on Azure Docs. Oh. That's what's here interesting, but there's like other things like data. What else am I working on? Logstash, application insights, Black Hat Rust. I don't know what I'm doing with Black Hat Rust. Some other docs. And then you can look at things, and what our security researchers are doing is they look at graphs over time, so they can play the graph. It's just a nice visualization, but people that are doing investigations, they go really here step by step and see how social networks behaved over time. And for them, it's quite useful to do those kinds of things. Yeah, I'm using it most of the time, and for things like, I probably can't show that here. Otherwise, I'm using it to find, for example, let's do it here. I haven't tried it before, but you know, the demo gods may be with me. I'm using it to visualize. So now I can find out, for example, let's label the entity name. Entity type is okay. Let's have a kind here. So from this events from live stream, there are a couple of update policies for populating another table. And then on this table, there's this reference data, which is joined together, obviously. I have not seen the schema before, okay? It's the first time that I'm seeing it. And then based on this, there are probably functions which are combined. Oh, there's another update policy, which is this. Another update policy, which is this. And then I bet there must be also sometimes at some point also functions. So what you can do with this technology is, this is a function, for example, okay, a function. And obviously this function is combining data from an archive and data from a live stream. And you see there's a lot of data going into the live stream. There's a couple of things which are not really connected here. A couple of update policies. I don't know what this is. Repositories in scope. Okay. I don't know what this is. Yeah, and you consume it using events all, and this is combining like archive data and other data. So it's at some point, you know, when I'm getting questions sometimes from customers, say, why is this slow? Why is this function slow? Then you can look at this and say, okay, because this function that you created, because also tracking functions and functions that embed functions, it's connected to this other function, which is populated by this table or used by this table, and which is having an update policy, putting data into it. So it's nice to trace. Okay, wow, demo gods are with me today. I like it.
Something at the moment you created, Kusto database and function everything within it. That's just something that you can query that's there.
Yeah, correct. Yeah, no, it's just generated here.
Something like that for other databases.
Yeah, just to right click and say show entities graph. We are doing that, but you know, Ignite is coming.
I guess you don't have to comment on it. I guess you will expand this to other Fabric workloads.
You know,
you don't have to.
Not maybe.
The video is gonna be published after Ignite anyway.
Might be, yeah.
Probably a Fabric block entry.
Yeah. I usually do only. I also do sometimes Fabric.
Yeah.
But then it's not. I can't use too much of Kusto. Okay, let's look at some real-world use cases. And here it gets like really super interesting. As I said, we're working together with security researchers. And this is an exposure graph. So an exposure graph, it's something that also the Sentinel folks are working on. It's one of their products. And they're explaining how they are creating the exposure graph and what kinds of queries they're running on with it and how they're doing it with Kusto. So they have assets and what they can do with those assets, like a virtual machine or a storage account. This is an asset. Also, there are also other types of assets. And they're tagging certain assets with, okay, they have a high criticality and they can do things like blast radius analysis, attack path stuff. That's what they're doing with this type of technology. Manufacturing ontologies.
Ontologies get even more
Evil.
interesting in building management.
Oh.
I had a project there.
Erich Brandstedt today.
Yeah.
Yeah.
Erich Brandstedt, we can talk about him. He's responsible for standards at Microsoft now lately, and he's worked together with him on OPC UA topics, and he. Yeah. Okay. I don't know. It's for me, it's just data and connected stuff. And Erich adds all of the semantics to it from this domain of industrial IoT. And I look at it and say, okay, so where's the data that I can create a graph from, and how can I help you with time series? And he is creating adding the logic for it. Yeah, but we created even a reference architecture, a Microsoft reference architecture, which is quite an investment. And you mentioned buildings, of course. I can mention Bosch because we have a public story with them, Bosch and Building Technologies. This is something that's super relevant and super interesting.
But there they have building world. There are different competing ontologies. And depending on which way you go, you end up in religious wars. Which happened to me, which is not a fun place to be.
Yep.
It sounds like a lot of fun, but it's not.
Yep. I think this is what I'm exactly. I was working together with Bosch and created this a graph scenario. I'm documenting a couple of graph scenarios quite deeply. At the moment, I'm working on a resource graph and document how a resource graph could be built with the technology like Kusto. And this one is talking about the ontology of that, like Bosch open source their ontology, their building ontology. And I'm using their ontology to populate a digital twin, an Azure digital twin, and then I'm historizing all of the data from Azure digital twin. So the relations and also the properties into Kusto, and then I show how to use Kusto instead of Azure digital twins.
Trying to remember what the different ontologies were in that.
Yeah. It's
somehow my brain, to protect me from bad memories, has deleted all that and replaced it with listening.
Yeah. So there are a couple of interesting things out there, and what is more like there's probably in the future what we're going to see more is like security stuff, cybersecurity stuff will become more prominent in all of these scenarios. And what we see right now, we went GA with the feature in September. Oh wait, no, GA. We were in September last year was public preview, and on 23rd of May, to 235. That's why we've chosen that date. Is we went GA with that feature, and since then, like it's crazy. It's growing like super nicely. We have nice large customers who are betting on it, and it's just fun to be PM for that. Yeah, so I don't know what else I have. A couple of more infos. You can go and search for the new operators. Just this week, or last week, also on Friday, I released we released 2 new operators. One for finding shortest paths between nodes, and also one to mark components. So sometimes you want to have something that's called connected components. So if you have a graph, you want to do some little bit of like math, not too much. and find out like where are like specific clusters or components of the graph that belong to each other. For example, families that are connected with each other. If there would be multiple families and you would add them into a graph, we would assign them with a specific identity.